Okay, the first part of section 5.4 is to factor. So this comes from standard F.4, which says I can factor polynomial expressions. So of course, when we're dealing with factoring, you always look for the GCF first. When there's 4 terms, you're going to factor by grouping, and we're also going to take a look at some special patterns. All right, so first, special patterns when factoring. Sum of 2 cubes. So when you have a cubed term, a cubed plus another cubed term, we'll say b cubed, it's going to equal this set of this expression here. So you're going to take a plus b, so you're going to actually take the the cubed root of a cubed, and whatever you get goes in the first parenthesis. Then you're going to take the cubed root of b cubed, and that goes in the second set, or the second piece of that parenthesis. All right, then you're going to multiply that by a trinomial. So a squared, so you're going to square the a term, then minus a times b, and then plus b squared, you're going to square the b term. All right, so that's you're going to have to memorize there. So we have sum of 2 cubes, and we also have difference of 2 cubes. So a cubed minus b cubed, the same thing happens. Now the only difference here are the signs. As you can see, they both start with a's, then they have b's, then they have a squareds, they have AB, and they have B squareds. So the signs change. You have a plus, minus, minus, plus, plus, plus. To remember those signs, you're going to use this acronym, SOAP. All right, SOAP stands for, the S is the same sign, the O is the opposite sign, oops, that's N, and then the AP is always positive. All right, so let's take a look at this. If it's sum of 2 cubes, same sign would be positive, opposite sign would be negative, and always positive is a plus. All right, if we look at the subtraction one, if it's a minus here, the same sign is a minus, the opposite sign is a plus, and always positive is a positive. All right, so let's take a look at these examples. The first one, 8x cubed plus 27. So you're going to take the cubed root of 8x cubed. All right, so you're going to do that separately. The cubed root of 8, if you don't know that's 2, you could put that in your calculator. All right, and then the cubed root of x cubed is x. And then you're going to take the cubed root of 27. Again, if you don't know that's 3, you're going to put that in your calculator. All right, so the first set of parentheses is the 2x plus 3, same sign. And then you're going to take this 2x and you're going to square it to figure out what goes in the next set of parentheses. So 2 squared is 4 times x squared is 4x squared. Then you're going to take a times b, so 2x times 3, which is 6x, so that goes in the middle. And then you're going to square the b term, which is 9. All right, and then again, we're using SOAP for our signs. Same sign, opposite sign, always positive sign. All right, you could do the same thing with the 64x cubed minus 1. The cubed root of 64x cubed is 4x. Same sign is minus. Cubed root of 1 is just 1. 4x squared gives us 16x squared. Then multiply the 2 together. 4x times 1 is 4x, and 1 squared is 1. And again, we're going to use SOAP. All right, so let's go ahead and take a look at these examples. All right, so example 1, we are going to factor y cubed minus 4y squared minus 12y. So of course, we always look to take out a GCF. We could take out a y in each of these terms. When you divide out a y, you're left with y squared minus 4y minus 12. All right, now we've looked at this before first semester. We have a trinomial where the leading coefficient is 1, so we're going to set up an MA table. We need 2 numbers that multiply up to a negative 12 and add up to a negative 4. So those factors are negative 6 and positive 2. So we have y, then we have y minus 6, and y plus 2. So that would be our answer. All right, part B, again, we're looking at a GCF. So we're going to take out we could take out a 3x out of all of those. When we take out a 3x, we're left with 5x to the 4th minus 24x squared minus 36. All right, can't take anything else here. Now we have a trinomial where the leading coefficient is not 1, so we are going to have to factor this by grouping. So first we multiply the 5 and the negative 36, and we get a negative 180. So we need two numbers that multiply up to negative 180 and add up to negative 24. All right, so start going through your factors. All right, so 2 times 90, that doesn't give us 24. 3 times 60, that doesn't give us 24. 4 times 45, that doesn't give us 24. All right, then check 5. 5 goes into 180 36 times. Then that doesn't give us 24. All right, 6 times 30, you'll notice, has a difference of 24. Since it's negative 24, this is going to be a negative 30. So negative 30 and 6 are your two factors. So rewrite your 3x out in front. Okay, then we're going to rewrite the first term. So 5x to the fourth. Rewrite the last term, negative 36. So far, none of this is new. This is all first semester. All right, the only difference here is before we were just used to writing the factors with an x. Well, now if you look at this middle term, the middle term is an x squared. So now you're going to write this as negative 30x squared and a positive 6x squared. Okay, so you're just rewriting this into two new pieces. So the x squared has to stay with it. If it was x cubed, you would write x cubed with it. X fourth, x to the fourth, and so on. All right, now we can go ahead and factor this by grouping. I'm going to rewrite my 3x. All right, now I'm going to take out between a 5x and a negative 30x. I can take out a 5, and then I can also take out an x squared. All right, so if we look here, when we take out a 5x squared, we're just left with x squared. When we take out a 5x squared from negative 30x squared, we're left with minus 6. Okay, the next two, I could take out a positive 6, and I'm left with x squared minus 6. These two better be exactly the same or you did something wrong. So now we have our GCF of 3x, we have our x squared minus 6, and we have our 5x squared plus 6. Okay, word of caution, whenever you have a term that's not an x, go ahead and double check and make sure you can't break it down further. All right, the only way you could break down two terms would be difference of cubes. Since 6 is not a perfect cube, or a perfect square, difference of squares, sorry. Since 6 is not a perfect square, that's all we could do. So that would be the factoring. All right. Part C, we have 5g to the fifth minus 80g cubed. So again, we're going to take out a GCF. So between 5 and 80, we can take out a 5. Between g to the fifth and g cubed, the smallest is g cubed. So then we're left with g squared minus 16. All right, again, whenever that term is not to the first power, make sure you can't break it down. This one is a difference of squares because it is a minus sign. G squared and 16 are both perfect squares, so we can break that down. Rewrite your GCF. G plus 4 and g minus 4. Now that they all are singular terms here, you can't break it down anymore. All right, let's go ahead and take a look at our perfect cubes. All right, whenever you have a plus sign in a cube, you're going to look for perfect cubes. All right, so let's look here. 27x cubed, that's our A term. So if you take the cubed root of 27, you get 3. The cubed root of x cubed is x. All right, then the B is the cubed root of 125, which is just 5. All right, so we're going to take that and write that as a binomial. So we have 3x and 5. Remember to use SOAP, so same sign since it's plus. Plus goes with that. All right, now we're going to go ahead and square the A term. When you square that, you get 9x squared. So that's the first part that goes in here. All right, now we need the opposite sign for SOAP. So that's minus. Then A times B. So 3x times 5 is 15x. Then the always positive part of SOAP, and then B squared, which is 25. So this is your answer. 3x plus 5 times parentheses 9x squared minus 15x plus 25. All right, let's try one more. So now we have negative 2d to the fifth plus 250d squared. So you're going to take out GCF, make that first term positive. So we have negative 2d squared, and we're left with d cubed minus 125. All right, so we have a perfect cube here. We have a perfect cube here. So now it's difference of cubes. So we're going to rewrite the GCF. Okay, the a term, if you have d cubed, the a term is d. So d, same sign as minus. B is the cubed root of 125, which is 5, so d minus 5. Square the a, we get d squared. Opposite sign is plus. A times b is 5d. Always positive sign is plus. And b squared is 25. So that's my answer. All right, and the last type of problem factoring is just factoring by grouping, which we've done when we looked at the trinomials where the coefficient wasn't 1, but now we'll just take a look at these separately. All right, so GCF of everything, there usually isn't, but you still should check to see. Now we can go ahead, I'm going to rewrite this over here just so I have a little bit more room. Okay, so you're going to take the first two terms, group them together, second two terms, group them together, find a GCF. So here we can go ahead and take out a 9t squared, and we're left with 3t plus 5. And here we just want to take out a negative 1 to switch the sign, so we have 3t plus 5. All right, so we have 9t squared minus 1 as one factor, and 3t plus 5. Okay, remember my warning. You always want to look and see if the variable has a coefficient, or not a coefficient, a exponent that's not 1. You want to see if you could break it down. Chances are in this section, in this chapter from now on, you will be able to break it down. So here we have t squared, so our only option is difference of squares, which it is. So we can break this down into 3t plus 1, 3t minus 1, and then don't forget your 3t plus 5. All right, second one, we can go ahead and break this up. All right, for the first two, we can take out a 5b squared, and we're left with b plus 3. For the second two, we can go ahead and take out a 12, and we're left with b plus 3. Again, make sure these are exactly the same or you did something wrong. So now we have 5b squared plus 12 times b plus 3. The b plus 3 you don't have to worry about because it already has a coefficient or an exponent of 1. The b squared you do have to look at, but since it's positive, there's no sum of squares. So that would be my answer. All right, so now I want you to go ahead and try these three problems. There's one from each example. These will be due at the beginning of class tomorrow.